Okay, so good afternoon, or well, good morning to some of you. This is Miss Andrews, and we're talking about similar figures. Today's day two of similar figures, and I thought I'll record the lesson for you so we don't miss a beat. So before we get started, I want you to go ahead and do your do now. Your do now is this first portion here. You're filling in based on what we talked about on similar figures day one, and identify the corresponding sides and angles on here. Remember when we use the highlighter to determine what goes with what on each one? Go ahead and do that. So the video will be paused so you can do that. Okay, so that means you've been given 5 minutes to complete the do now. So now we're going to go ahead and talk about what should have been filled in. So similar figures, in order for figures to be similar, they must be what? Be the same shape. If they're different shapes, then they cannot nowhere be similar. The corresponding angle measurements must be congruent, which also means the same. The corresponding side limbs must be proportional. And when you went to do the shape here, you could use the little tally marks we talked about to say that each one of those sides go with the other, or you could have used highlighters to distinguish what goes with what. And for the angles, we know here angle A, we know will go with angle D, angle B with E, and C with F. And what that look like as words or in math language, angle A, angle B, angle C, with the congruent sign goes with D, E, F. And for the sides, we can say AB, BC, and AC are similar to DE, EF, and DF. So if your do now doesn't look somewhat similar to that, make sure you update it with any information you've been missing. So now let's talk about, and in some of our classes we did talk about what's the difference between and within. So when we're talking about between, that means that the corresponding side from each figure is equal to the corresponding sides from each figure. So what that would look like, for example, say if we put numbers on here. So if I said 3, 2, 1, and then for this one, if I use 6, 2, 4, if I'm talking about corresponding sides, if I was to use the the purple AB, so if I did AB to DE, because AB goes with DE, number wise, that would be 3 to 6. And I'm saying I would set that equal to if I did another set that were corresponding. So maybe let's see here. Let's try BC. So if I did BC, we'll go with EF. So number-wise, that will be 1 over 2. Now, you know I like to use a highlighter so you can kind of see what was what. So we used the purple on top of each other because they were corresponding. And then we used the yellow on top of each other because those are between. So between means if I take a corresponding from each one of them and set it equal to another one. And that makes sense because 3/6 does simplify to 1/2. So these are equivalent, which lets me know that they are corresponding or similar figures. So let's talk about within. Within just means that I'm going to take two sides from the same shape, and then I'm going to take the same corresponding to those from the same shape. So if we use the same letters, this time I can say AB to BC. So AB to BC. AB is 3. BC is 1. And if I said that's equal to, I would use the same setup. So here it'll be DE. So I'm going to say over here DE to EF. And that number-wise would be 6 over 2. So color-wise, remember we started out with, for within, we did purple and then yellow. On this one, it was purple and then yellow. And if we were to simplify these, we would see that this is just 3. 6 divided by 2 is also 3, so they still are corresponding. What do you notice about between and within? Well, one thing I noticed is that when we're talking between, the corresponding sides are on top of each other. Take a look. When we're between, you notice these are corresponding, so they're the same color and they're on top of each other. On top of each other. But when we're talking about within, the corresponding sides are across from each other. So when you look here, they are across from each other this time. So that's the difference. So now we're talking about finding a missing side length. So what happens when I have a triangle like this and I don't have a side? Well, when there's no side, we know that means that there's an X that exists there. So similar figures have corresponding side lengths when they are proportional. When two figures are similar, a proportion or a scale factor can be used to find the length of the unknown side. So first I need to identify what goes with what. So this time I am going to use my highlighter or color pencil. You can use either one. So I know this side goes with that side. So AB goes with DE. BC goes with EF. And I'm going to stop there because those are where my numbers are, and that's what I need to use. So if that's the case, if I was to do between, I'm going to just say B for between, Remember, between means corresponding are right on top of each other. So that means 6 to 4, 6 to 4 is equal to 8 to x. So here I can cross multiply and divide to solve for x. 4 times 8, so 6 times x is 6x equals 32. When I divide both sides by 6, I'll get x equals 5.3 repeating. If I did within, and I want to make sure we see exactly what I did here. I used those colors and then those colors. If I did within here, that means that I can say purple to yellow. So I can say 6 to 8, which would have been purple to yellow, is equal to 4 to 6. So what does that mean? And I can check for my within. I should have the same color across from each other, so I know I got it set up right. So if I go to cross multiply, oops, wait a second, this should be x. When I go to cross multiply, you'll see what happened here. It's the exact same setup. Nothing changes. So what does that tell us? You can use between or within interchangeably, and you're still going to get to the same answer. So do it matter to me which one you use? Absolutely not. Use whichever one comes natural to you, but just know that sometimes if there's a multiple choice, you might have to look and see, is it a between situation or a within situation to find my answer? Now let's go practice more. We have 3 examples here. I'm going to work through, well, we just did a triangle example, so I'm not going to do this one, but I'm going to do a rectangle, well, a rhombus, and then this triangle because this is a special triangle. So here, when I identify, so I know my longs go together and my short sides go together. Now, if you look here, it doesn't have anything listed. So if it's something not listed, I know there's an X there somewhere that we got to find what is missing there because this side has a number. It has a 6. So which method should we use? I'm thinking we're going to go ahead and use between. So I'm going to just put a B, and I'm using the between method. So this time I'm going to use the purple to purple, which is 21 over 7, and then the yellow to yellow, 6 over x. So if you notice, these are proportions. These are things we've done many times, so I know for a fact that you're capable of doing this. So when we go to cross multiply, 7 times 6 is 42. 21 times x is just 21x. So 21x equals 42. Now I need to solve for my x by dividing both sides by 21. And when I do that, I get x will equal 2. So that means this side here is 2. That's all that means. Let's try the next one. This time we're going to use within. Now, whenever there's a triangle within a triangle, don't get confused. Your best thing to do is to draw 2 separate triangles to separate these two. So I know I'm going to have a big triangle, and then I'm going to have a small triangle. Now, because the small triangle is a little easier to identify what numbers go with it, I'm going to add those numbers to my triangle first. So 3x 2.5. All right, so I know that's all taken care of. Now let's talk about the big triangle. The big triangle does not stop here, so I cannot say it's 4.5, but it does go all the way. So the big triangle goes all the way here. So what do you think I need to do with these two numbers? I need to add them together. So 3 plus 4.5 That's 3, that's 4.5, 6, 5.5, 6.5, 7.5. So that means that this becomes 7.5 for that side. This is 9, so I'm putting 9 here. And this side, it doesn't give me the full number, so I don't have to put anything there because all I had was the number for the small one. So I'm going to use the measurements that's going to relate to help me get with my x. Because it didn't ask me to find this as an x, it just wants me to find this bottom one. So go ahead and identify what goes with what. So I know this 7.5 corresponds with 3. I know this 9 corresponds with x. And if you want to identify the third side, you can say those correspond with each other as well. So we said we're going to use within. So if I'm using within, I'm going to go ahead and say 7.5 over 9. So purple over yellow. So 7.5 over 9. So I did purple over yellow. And if you have to keep using the little markers to remind yourself of what way you did this, please don't stop, because my goal is that you are so successful that you can do it without adding all the extra colors. But if you need it, then do it. So that's purple over yellow. So I'm going to do purple over yellow on this one as well, equals 3 over x. That is the within method. Because remember, we said within means that the corresponding sides are right across from each other. So purple is across from purple, yellow is across from yellow. So now we can cross multiply and divide. 9 times 3 is 27, is equal to 7.5x. I divide both sides by 7.5. And when I do that, I'll end up getting that x is equal to 3.6. So right here is 3.6. Now it's time for you to try. I want you to go ahead and do this one on your own. You got 4 minutes. And when you have it, do a thumbs up, and your teacher will come and check that for you. So pause the video. Okay, thank you for coming back. All right, so let's check your work here. So for here, this time I'm not going to use color. I'm just going to use markers. So I know this goes with that side. That goes there, and the bottom will go with the bottom. So I just need to make sure whatever sides I use have the x involved, right? So this time I'm going to use this over the double line. So a single line over the double line. So the single line will be x over 25. And so then on the next one, I'm going to do single line over double line. So it'll be 6 over 10. And so now we will cross multiply and divide. So it becomes 10x is equal to 150. When I divide by 10, x should have just been 15. So that means that this number here is 15. All right, now go ahead and try it with your partner. So you and your partner can use your own papers, but discuss how would you solve this and give it a try for yourself. And when we come back, you'll see the answer. Pause the video. So I hope the first thing you did was go ahead and separate out the triangles. And remember, 6 and 4, this counts as a whole one side. On the small one is 6 and x. On the big one is 6 plus 4. So that means this is 10, this is 15. So if I said this is a 1 marker, this is a 2 marker, that'll be a 1 marker, this would be a 2 marker. So if I did 6 over x is equal to 10 over 15, Then I can cross multiply, and I get 10x is equal to 90. Divide both by 10. X equals 9. So this will be 9. Great job if you got it. If you don't worry, you have practice. We're moving to independent practice. So for this part, you're working with a partner. You're going to choose which one you want to do. The oldest person in your partner group will pick first. There are 6 problems to pick from, and this is what you'll do into the duration of class. If you have any questions, please ask your teacher.